Hello and welcome. Today we're working on how to calculate interest payments in Excel. This is a special function in Excel called PMT. So the PMT function is one of the time value of money or one of the financial functions in Excel. Hello, my name's Jeff from Finally Learn, where I help you finally learn financial skills. Now, time value of money is the topic. Sometimes it's called financial functions. Both of those are equivalent. So there's 5 financial functions in Excel. The first one is the future value. We've done a video on the future value. That's a lump sum at the end of the problem. The next one is present value, which is a lump sum at the beginning of the problem. Payment is our video today. We're trying to figure out what is the amount of the payment. It's a stream of equal payments, also called an annuity. Could be positive, it could be negative, depends on the situation. We'll show you how that works. Then our next couple of videos in the future will be the rate function, which is the periodic interest rate, and then the number of periods. We're always going to work with either years or half years or quarters or months. So make sure you know if it's a monthly problem, it's not 5 years, it's 60 months. Now just one note before we get started, present value and future value are opposites, and so a lot of times present value is negative and future value is positive. So let's look at our first little problem here. So let's assume Morgan buys a car for $26,000. Her interest rate is 6%. It's for 5 years, which is going to be 60 months, right? We're making monthly payments. What's her monthly car payment? So this is, everyone wants to know how to calculate a car payment. So here's how you do it. The periods per year, we just set up a template here, is 12. The payments, this is an Excel feature. You need to put either 0 or 1 if the payments happen at the end of the period or payments happen at the beginning of the period. We'll put 0, assume the payments happen at the end of the period. The number of periods is going to be 5 years, or is it really 60 months? Well, it's going to be 60 months because we're making monthly payments. The annual interest rate is going to be 6%. The present value is $26,000. Now, does that need to be positive or negative? Well, we're borrowing $26,000, so it's like we're receiving $26,000, and we're going to make a payment of some amount each month to pay that loan off. And the amount at the very end is going to be 0. So we need to calculate the payment on this loan. What does it take to pay off this loan in exactly 60 months? It's going to be the same payment every time. Now, to do the formula, do the Excel function here, I'm going to use the FX, which pulls up the function. So insert function. I'm going to search for PMT. I did it recently, so here it is at the very top. So PMT, I'm going to search for the payment. And Excel kind of reminds us here, says, hey, you need to use the periodic interest rate. So our periodic interest rate is going to be 6% divided by 12. So that's the reason why I lay it out like this. I'm setting up a template so you can solve this every time, and we'll have some thoughts at the very end of the video, so stay tuned and watch all the way to the end, and you'll see how we think about doing a template rather than just doing a formula one at a time. The number of periods is going to be 60. The present value is going to be 26,000. The future value is 0. And the type, well, the payments happen at the end of the period, so it's 0. So our answer is, did I mess up somehow? I have an equals up here. I don't need an equals. So the payment every month is going to be $502.65. So if you buy this car for exactly $26,000, exactly 6%, exactly 5 years, 60 months, your car payment is going to be $502.65. You'll make that every month at the end of the month. So let's do a couple little things, just kind of make some analysis. And I've done this on all the other problems, and I'm not going to show you each time. But you could take 60 months. A lot of our problems are going to be monthly, divided by 12. So this is 5 years. You can kind of see, hey, this is for 5 years. Well, what's our total payment? Our total payment is going to be the 60 times the 502. And this comes out to be negative, which is fine. The total of the payments are going to be $30,159. We're happy to leave it negative, but if you want to manage it, we can put a negative in front of it. And the total payments then are $30,159. You need to know this. If you paid cash for the car today, you'd pay $26,000. But if you finance it over the 5 years, you're paying $30,159 for this car. Now, the last thing is, I like to show the formula, and you might say, hey, wait, I can't really see the formula. It's too small up here. So there's a little function called formula text. So formula text, and point to a cell. You want to see what the formula is. So this just shows the formula. So here's what we did. We pointed to each one of these. This is the function payment, and I do this every time so you can see it's the same formula or the function every time. All right, the next one is, this is a home loan. A lot of people want to think about, well, let's look at a home loan. So let me get rid of all this. And I have the years, total payments, and the formula text already showing, so I'm not going to show that again. But let's say Ricardo buys a home for $260,000. He pays 5% interest for 30 years. What's the monthly loan payment? Well, the periods per year is going to be 12. Their payments are going to happen at the end of the period. The number of periods is going to be 30 times 12 is 360. So that's the 30 years. The annual interest rate is 5%. The present value is $260,000. We're going to put it as a positive number because Ricardo is receiving the $260,000. We're going to figure out the payment in just a second, and the loan happens to be 0 at the end. We're paying it off over 360 months. So the same formula, you'll see this is the same problem that we had just a minute ago, just change the numbers. The rate is 5% divided by 12. The number of periods is going to be 360. The present value is $260,000. The future value is 0. And the type is going to be 0 because the payments happen at the end of the period. So what's our answer? Well, our answer is $1,395.74. So your payment is approximately $1,400, $1,400. Now, how much total are you paying? Well, 360 times that $1,395, you're paying $502,000 over the 30 years. So you might say, hey, that's a lot. What if I only pay it over, instead of 30 years, what if I pay it over 20 years? So make this 240, and the payment goes up to $1,715, but the total payment, since you're only paying 240 of those, the total payments go down to $411,812. So you save about $95,000 by paying off 20 years early. So it was 502, and you would save a lot of money if you did it over 20 years. So you can calculate that. All right, the next one is, let's do a credit card, and I'm going to set this up. Now, my purpose here is not to try to encourage you to have a credit card. I'm trying to discourage you to have a credit card, to pay off that balance, not carry a balance. It's a really, really expensive thing, and we'll show you how this works. So let's say BC has an 18% credit card with a $6,000 balance. The minimum payment is $120. What is the payment needed to pay off the credit card in 24 months? BC's gotten serious, like, hey, I don't want this credit card balance anymore. How do we pay it off? So we can calculate the payment. Now, I've done the payment here just like before. You'll see it's the same problem. If I switch tabs, it's the same problem. So I'll show you how to do it. But let's get started with this. Periods per year is 12. The payments happen at the end of the period. That's a 0. The number of periods, we're going to try to pay this off in 24 months. So let's see what else. Our rate is 18%. The present value is $6,000. We're going to make that positive, and the payment happens to be 0. I'm sorry, the future value is 0, and we're going to calculate the payment here. So this pays off in 2 years. What's our payment each month to pay off this credit card? All right, so we're going to do payment. Our rate is going to be 18%, but that's not per month. That is for the entire year, so we divide by 12, but that's 1.5% per month. The number of periods is 24 months. The present value is $6,000. That's positive. The future value is 0. And the type, payments happen at the end of the month. you're going to have to make a $299 payment, essentially a $300 payment every month to pay off this credit card. So you do that in 24 months. So you've paid off a $6,000 balance with $7,189. You see this formula is just the same as we had before. The total payments are $7,189. Well, you say, hey, that's kind of expensive, $300 per month. Well, I calculated, and I'm going to punch in the numbers. I can show you how to do this when we calculate payments, the number of periods rather, but just for payment purposes. What if you paid $120? Well, if you paid $120, that's going to take you, now I calculated this before the video, it's going to take you 93.11 months to pay off this credit card. Okay, so your payment is $120. It's going to take you 93 months, which is almost 8 years, which means you're paying $11,173. So having the goal of trying to pay it off quicker than the 93 months, 36 months would be 3 years, right? $216, almost $217, 24 months, you would have to pay $300 per month. So paying off that credit card is very expensive. If you the longer you take, the shorter the time, it's going to take more dollars to make that payment, but it's going to reduce your total payments. All right, the next one. Let's flip it. Instead of saying a loan, let's say we want to have $1 million. All right, I'm going to leave my payment calculation. It's the same as before, but I've used a template. So this calculates it every time exactly the same. So all we're doing is just changing numbers. Now, let's say Drake wants to have $1 million in 30 years. He can earn 9%. What amount does he need to save each month? And apparently he hasn't saved anything so far. So it's going to be 12 periods per year. Payments happen at the end of the period. The number of periods is going to be 360 months. So that's the 30 years. You see it's divided and got the 30 years. The annual interest rate is going to be 9%. He's trying to save and get to $1 million. So $1 million. And he has zero right now. He got started with zero. So if he wants, in 30 years and 360 months, he wants $1 million and he can get 9%, then he needs to start saving $546.23. So this is a payment that he has. But what if he says, hey, wait a minute, I actually have $10,000 that I've saved already. So put that in as a negative, $10,000. $465 is how much he needs to save every month now. So it changes. So this is a template, how that works every time. We have one more and we'll talk about the template. All right, what if this is the retiree kind of problem? What if you have an amount of money and you want to withdraw? How much can you withdraw every month? So it's the same problem. You see, this is the same function I have every time. So let's say JJ has a portfolio of $1 million. So $1 million is going to be, and I'm going to make this a negative $1 million because we're basically putting that into the account. You're trying to receive how much you're going to have cash receipts. You're trying to pull money out of that account. So we're doing it monthly. And it's for 20 years. Payments happen. We're going to assume beginning of the period. Little trick here. You need to make sure beginning. So this is going to be 1. The number of periods is going to be 240. That's over 20 years. The annual interest rate is going to be 8%. And the future value is going to be 0. So let's think about this problem. And we did the payment just like we would otherwise. So if you have a portfolio of $1 million and it earns 8%, what is the amount you can withdraw? And you just want that money to last for exactly 20 years. If you can get exactly 8%, then you can withdraw $8,309 every month. And then the end of 20 years, you have 0 balance. And what's happened, because you have an investment, then you've actually taken out $1,994,162. So I want you to be in this situation where you have money you're investing and getting an interest rate rather than the credit card. So you want to be in this situation. Well, what if you say, look, I want that money to last for 30 years, so 360. you can take out $7,289 and you've withdrawn $2.6 million. So pretty fantastic. So you've seen, here's what I've done every time, is I've built a problem where I have the same payment. So this is using a template. I would list everything, point to that, so I'm not typing in a number here. So let's explain what this problem is. Let's say you have a friend that says, look, I'm going to do monthly payments at the end of the payment, at the end of the period, for 60 months or 5 years. I think I can earn 9% interest. I want to have $50,000. Right now, I have zero in that account. You would say you need to start saving $662.92 every month, and then in 5 years, you're going to have $50,000. And they say, wait a minute, I've already saved $4,500. Then you only have to save about $569.51. So I would work with a a payment template, PMT template every time. And so don't type the numbers in. I'm trying to use good practice and show you how this works. Hey, I hope this is helpful for you. If this is helpful, give me a thumbs up. Please subscribe to my channel and let me know what future videos you'd like to see. Hey, thanks for watching. Have a great day.